The first part of addition is combining two numbers to make another whole number. We will start first with concrete. So we've got 3 orange and 4 blue. So what we would do then is we would line them up, and you can use counters, you can use little compare bears, you can use just 2 things and add them up, and the children can then count them if they've got one-to-one correspondence. So that's 1, 2, 3, 4, 5, 6, 7. Once you've had a lot of experience of using concrete apparatus where they're combining 2 numbers, they can then move on to pictorial. So we can represent the 4 blue counters here, and then we can represent the other 3 counters here. We'll do a different shape, and then we are going to make these 2 parts into our whole, which will go here at the top. So we've got 1, 2, 3, 4, 5, 6, 7. We would then go to abstract, where we may then just go 1, 2, 3, 4, added to 3. So we would now use the digits, and this is our 2 parts that make our whole. And we're hoping now they may just not have to count on, but just put 4 in their head. 4, 5, 6, 7. And that is our first step in addition, where we are combining 2 numbers to make a whole number, another number. That's step 1. Step 2 in addition is counting on using a number line, where you would hope the child can keep the number in their head and start from that number. So we can do it on this type of number line, where they would start from 4, because they already got 4 in their head, but if they do need this, it can still count from there. 4, and then they'll go 5, 6, 7. We can use Cuisinart, where the child would know this is worth 4, and then they know this is worth 3, so they go 4, 5, 6, 7. This is something called Numicon we use in school, again concrete apparatus. They can see that that is worth 4, so they'd have 4 in their head. We're not starting from 0, 4, 5, 6, 7. 4, 5, 6, 7. So here now we have a bar model. So here we could have our 1, 2, 3, 4, and then our other 3, 5, 6, 7, and that makes 7 all together. 4 add 3 is 7. Here we can still do the part whole model. 1, 2, 3, 4, 1, 2, 3. Let me put them all here. 1, 2, 3, 4, 5, 6, 7. Then we can move to abstract. So we can go on a number line like we did in the concrete model. So we can go 0 to 4. We can do the little jumps as well if you want to. 0, 1, 2, 3, 4, and then count on the other 3. 4, 5, 6, 7. Going from this pictorial to this abstract, we can literally just put the numbers 4, add 3, put the 4 in your head, 4, 5, 6, 7. That's our bar model. And again our part whole model. 4 combined with 3, 4, 5, 6, 7 equals the number 7. Step 3 is a really important concept where children need to regroup numbers to make 10. We have lots of different concrete apparatus the children can use. We have these 10 frames here where they can physically put the counters on. So we can see that it's 1, 2, 3, 4, add 6, make 10. We also have the Cuisinart where we know that is worth 10. So when the children know what these are, so that's a 7 and a 3 make 10, and an 8 and a 2 make 10. We also have Numicon, so we can see that's 10, and the children can place them over and see that's 3, add 1, 2, 3, 4, 5, 6, 7, 3 add 7 make 10. And we also have these handy tens frames and strings as well, where they can change them over and do combinations that make 10. That's all concrete apparatus. From the concrete to the pictorial. So if we look at making numbers to 10, you can go 1, 2, 3, 4, 5, 6, add 4 equals 10. We can go to the part whole model. 1, 2, 3, 4, 5, 6, add 4. We're a little bit small, but we could squish in all the 10 there. 4, 5, 6, 7, 8, 9, 10 in there. Or we can go to this bar model. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equals 10 underneath. We could even write the number there as well to signify 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the abstract, you will then use digits. So we would go 6, add 4, and these fit in easier. 6, add 4, total 10. We could still use our number line. We can start from 0, jump onto the biggest number 6. If you want to do mini hops in between, 1, 2, 3, 4, 5, 6, and then count on 4, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. And then our pure abstract model is when we come to use our number sentence, our equation. We do teach them that whatever is on this side, this is the important bit, whatever's on this side is equal to this side. It's not greater than and it's not less than. If we have this equal sign, it's equal. So we can say 6 add 4 equals 10. We can write it the other way around as well. 10 equals 6 add 4. And just to blow their minds, we could also say 7 add 3 is the same as 6 add 4. They are still equal. The first stage of addition in year 1, and it focuses on adding 2 single-digit numbers that cross the tens. So the children have to have a really firm knowledge of our place value system, that we have 1s and we have 10s in our numbers. So if we're just taking 8, add 4 of 8, 9, 10, 11, 12. And the children can physically then change these 10. I'm not going to do all 10 because I'll be here forever. And we can change those into that. So we get 12 and they can physically see very clearly that that's a 10 and 2 1s is 12. We could do the same here. We've got 8 1s, add 4 1s, that's the wrong way around. 8, 9, 10, 11, 12, and we could exchange these 10 for that 1. So again, 10, 11, 12. We can do the same here with our Numicon, 8, 9, 10, 11, 12. And when we put our 10s frame over it from the Numicon, again you can see that that's 10, 11, 12, it's a 10 and a 2 in the 1s column. If we use our 10s frames, we can use it by drawing like this. So we've got 8, 9, 10, 11, 12. We can move 2 of these there to make a 10. Take those 2 off. And we have 8, add 4, makes 12. And we can do it physically, which is my favourite one, this. 8, add 4, we can take 2 off there. 8, 9, 10, so there, nearly, 11, 12, and we can really see now that that's 10 and 2. Going from the concrete to the pictorial, we've now drawn our 8 counters and our 4 counters, and we're now going to recombine them. So we've got 8, 9, 10, so there are 10s, and we can now take this 10 and place it here. So we have 1 10 and 2 1s. 8 add 4 make 12. In the abstract, we can go from the part whole model, so we have 8 add 4, that's a single digit and another single digit. When we add them together in our part whole model, our whole becomes a 2-digit number, 12. We can use a number line. We can start at 0 and do a big jump to 8, which is in our head that we count on from 8, count on 4, 8, 9, 10, 11, 12, and then the pure abstract is our number sentence, our equation. We use this equal sign to show them that it's equal on both sides. It's not greater than and it's not less than. Whatever's on this side is equal to this side. So we have 8 add 4 equals equals 12, but we also show them that we can actually have it the other way round as well. This is the second stage of addition in year 1, where we'll be adding teens numbers. So here we have 13, that's our 10 and our 3 units, and we're adding 2 in our concrete apparatus. So we've got 13 in our head, 13, 14, 15. We could use it with counters, 10, 11, 12, 13, 14, 15. We can use Cuisinart. The children, if they're familiar with the colours in the Cuisinart, they will know that's 13 and that's worth 2. It's 15, and you can see it's halfway along the 10, 15. We can use Numicon. There's our 13, and add these 2 here, that makes our 15. And we can use our tens frames. So we've got 10, 11, 12, 13, and the 2 off here, 15. And we can also do it physically with these great tens frames. Whoops. Stuck. Well, we've got 13, and then we can add the other 2. 13, 14, 15. Complete the pictorial. Here's our pictorial version of 13. We have 1 10 in the tens column and 3 ones. And we've got our 2 that we're going to combine. 13 add 2. So we've got 1, 2, 3, 4, 5 ones and 1 10. You can also use it as a bar model. We have 13 here, 13 X's, and our 2 here, which makes 15 if we counted all along. When we go for abstract, we can jump in our head from 0 to 13 straight away in one big jump, 13, and then 2 more jumps, 13, 14, 15, adding 1 each time. In our part whole model, we have our 13, add 2, makes 15. Our 2-digit number, add a 1-digit number, has made a 2-digit number, it's not across the tens. Our bar model here, actually just using the numbers, 13 add 2, make 15. And then again, going into our equation, our number sentence, 13 add 2, totals 15 in abstract form. This is the first step of addition in year 2, where we add a single digit to a 2-digit number. Many children will be able to do this in their head, but we will show you where we go from concrete to pictorial to abstract. So this is 24 add 3. So if we were doing it concrete, we go 24, 25, 26, 27. We can also do exactly the same with the discs, 24, 25, 26, 27, and move them across. We can do it with Numicon, 24, add the 3 is 27, and we can do it with the tens frames, 24, take these now, 24, 25, 26, 27, those 3 have gone onto there. From there we will then go to pictorial. We have our 2 tens and our 4 ones, which is 14, add our 3 ones. Let's count them, 1, 2, 3, 4, 5, 6, 7 ones and 2 tens. So 24 add 3 is 27. And from go to abstract, we've got 24 add 3 in our bar model, which makes 27. We've got our part whole model, we have 24, our large number, add 3 is 27. You can also still use a number line, but we're going to make a big jump from 0 to 24. So we're adding 20, starting from 24, and then we're going to count on our 3. 24, 25, 26, and 27. And then our pure abstract, our number sentence, 24 add 3 is 27. Reminding the children we can put it the other way around as well. And even 27 equals 3 add 24. There are 4 ways you can write it. The next step in year 2 addition is where we have a 2-digit number. We've got 24 here, it could be 54, 94, and we're adding another single digit to it. But when we add it this time, it will cross the 10, so we'll have to form another 10. So again, we start with concrete apparatus, that's 24, 25, 26, 27, 28, 29, 30. We can now swap those 10 for one of those, and it becomes 31. So we've exchanged that 10 for one of these 10s. We can do exactly the same here. 24 add 7. When we put that together, we can exchange that, and that becomes 10, 20, 31. With the number grids here, with the tens frames, 10, 24 add 7. We could take some of these X's from here, take that one, and that one, and that one, and eventually you would be just left with 1. Obviously you could do this with counters rather than X's. And then again it would work exactly the same here. We'd take all these over, we'd be able to exchange 10 of them once they were all combined, and we would still end up with 31 because that would be exchanged for those. Pictorial, we have 2 10s and 4 1s, 24 being combined with 7. 24 add 7. So we're going to try and see if we can make a 10 here. We've got 7, 8, 9, 10. So there's our 10, which would now be exchanged, and a 10 would be placed here. So we've got 1 1 left over, that one there, and 1, 2, 3 10s. So 24 add 7 is 31, 3 10s and 1 1. In our bar model we have 24 add 7, they could count on in their head and get 31. And in our part whole model, 24 add 7 is 31. We use these models and images because we can cover one up and try and work out what it is. What do it add to 7 to make 31? Or what is 31? 24 add 7, and that's why we use the bar model as well. Then we can go to our linear addition. 24 add 7 equals 31, reminding the children that it can go any way they like. And because it's addition, it's commutative, and it can go that way as well. This is the next stage in addition for year 2, where we're adding two two-digit numbers, a pair of two-digit numbers. I'm just choosing 2 small ones, but they could still be expected to add 84 at 84. So this we go 10, 20, we'd move this over 30. So we've got 30, 31, 32, 33, 34, 35, 36. Now let's say we were adding large numbers like 84 add 84. At some point then we could introduce this, but we're just sticking to small numbers for the sake of the board. Again, we could do it here, so we just put all the 10s together, so we'd end up with 30, 4, 6. Again, here, if you use these 10s frames, 10, 20, we'll put this over here because they can count in 10s, 30, and then we'd add the units, 30, 31, 32, 33, 34, and add those 2 onto there, 36. We do exactly the same with counters, 36. Now the pictorial. So we have 2 10s and 4 1s, 24, and we're adding it to 22. So let's look at our ones. 1, 2, 3, 4. We have 6 ones, and 10, 20, 30, 40. We have 4 10s, 46. We have 24 and 22 in our bar model, makes 46. We have 24 added 20 to 22 in our part whole model, makes 46. And then this is the new bit of learning we do in year 2, where we partition them formally. So we'll partition them into 10s and 1s. We have 2 10s and 2 10s, so we'll do the 10s first. 2 10s add 2 10s is 4 10s. 20 add 20 make 40. Now we look at our 1s. We have 4 1s added to 2 1s. 4 1s added to 2 1s is 6 1s. And we now introduce this very, very simple recording of where we can put it in a column. And it links back to this pictorial here, where we can see that we've got no 10s and 6 1s. So no 1s here, 6, and we've got our 4 10s when we combine those 10s and those 1s to make 46. And we can still do it in linear form as well. 24 add 22 is 46. And the final method we can do is, let me just rub that off so we've got some space. we can do a partition jot. So we can do it like this. 20, add 20 is 40. 4, add 2 is 6. 40 add 6 is 46. This is the final step in year 2 for adding a pair of 2-digit numbers where they will cross the 10. So we've got 24 and 17. Again, as I said earlier, we could go up to 84 and 27, and if these combined, we would then bring in the hundreds cube if we were doing a bigger number, but we're just sticking to a smaller number again. So we've got 10, 20, we combine them, we get 30, and then when we look at all of these and combine them together, we'll find that they make 11, so we can exchange 10 of them and we will end up with 40, whoops-a-daisy, 41, and we take those 10 away. It's exactly the same with our Numicon. 24, 34, just pop that up there for now. Added to with our 7 as well, that becomes a 10. So we've got 10, 20, 30, 40, 1. And you can see clearly that that 1 is left over. If we used our tens frames, we've got 24 add 17. So we do all the tens first. 10, 20, 30. And then we've got our ones left over here. So we've got 7 ones here. And we can take these ones, 7, and take that one. 8, 9, 10. Oh, we've got 1 left over. So then we get another tens frame there. And we've still got 10, 20, 30, 41 in our concrete. To get pictorial, we have 2 10s and 4 ones, 24 added to 1 10 and 7 ones, 24 add 17. So we've got 7, 8, 9, 10. So this here makes a 10. And this can now be exchanged for a 10 and put here in this column, like carrying a 10. So we have 1 1 left over. So that's our 1 1 left over. Then we'll count our 10s. 1, 10, 2, 3, and the one we've exchanged for 10s. So 27, 24 add 17 is 41. Going to the abstract, we can still use our bar model. 24 add 17 is 41, so we can record it that way. We can still record it as a part whole. 24 add 17 is 41. And this again is our method where we will take our 10s, our partition our 10s and our 1s. So we've partitioned our 10s, we've got 2 10s, add 1 10 is 3 10s. And then we have 4 1s, add 7 1s is 11 1s. And again, this is moving to the very, very simple first steps of column addition. So we have 1, 1 in the 1s, and 3 10s, add 1 10 is 4 10s, 41. Then we can do the partition jot, which is an informal method. 2 10s, add 1 10 is 3 10s. Then we've got 4 1s, add 7 1s is 11. 30 add 11 in the linear method is 41. These are the steps that we're going to follow for addition in year 3. Again, we start with concrete. We can use the base 10 equipment, which has been used in Key Stage 1, but it does get a little bit larger, so we tend to start to just use our discs. So we are adding 346. I'm just going to write that underneath anyway, so we know. And we're adding it to 287. So we've got all our counters out. So now we're going to try and group them into 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll then exchange those for one of these and put it here. So they can now come off our board. And what we are left with is 3 1s. Now we're going to do the 10s. So we're going to leave this one here for now, that we've moved from there, it's gone into this column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 tens we can exchange for 100. So let's take those off there and get 100. And that 100 can now go there. 1, 2, 3, 4, 5, 6. So now let's look at what we've got. We have got 3 ones, 2 tens, which is 20. Oh, no, I've forgotten to add this one. This is a mistake that lots of children make. Don't forget to count this one that we moved across. So let's try again. 3 tens, 3 ones, 1, 2, 3, 1, 2, 3 tens, 1, 2, 3, 4, 5, don't forget 6 hundreds. So 346 add 287 is 633. And we've done all that with concrete apparatus. Moving to pictorial, we have 346 combined with, added to 287. So we'll do our ones first in this column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will take those 3 and we can exchange those 10 ones for a 10. In this column we'll put that there, and we've got 1, 2, 3 left. Let's look at our tens column now. We have 2, 4, 6, 8. Don't forget that 9, and we can combine one of these 10. So that's 10 tens, which we can now exchange 10 tens for 100 and put the 100 there, so that becomes there. And again we've got 1, 2, 3 left over. So we've now got 3 tens, 3 ones. Let's look at our hundreds. 3, 4, 5, and don't forget the one that we've exchanged and put and carried over into this column. 6, 633. The abstract, where we need squares. So I've colour coded this and already completed it for you. So initially this is how we do it. We say 687 plus 248. So we add the hundreds first. So I've colour coded them, they're all black. 600 add 200 is 800. Then we've got the 80 and the 40. 8 tens, 80, 4 tens, 4 tens make 120. And then we've got our units in our ones or units in green. 7 ones add 8 ones make 15 ones. So then we can just add these up. 935. There's another way to expand it and partition into your hundreds, your tens and your ones. So this time we are looking at a column, and I've colour coded it again, so we will add our ones first. So in our ones column we've got 7 ones add 8 ones, 15 ones. Then we go to our tens column here. We have 8 tens add 4 tens is 12 tens. 80 add 40 is 120. And then we'll go to our hundreds column. 600 add 200 is 800. So all these partition values we can now total up, and we get a 5, 3 tens and 9 hundreds. Then we finally move to the method that we all learned at school, which is the compact shortened method. And we've got our ones still here. 7 ones add 8 ones is 15 ones. Now this time our 10 goes in the tens column, and children, because they've done it pictorially, because they've done it in the expanded form, seeing the 15 here, because they've done it with the counters, they now understand why this 10 is here and why it's being, as we used to say, carried. So then we've got 8 tens add 4 tens. Oh, and don't forget the 1 10 at the bottom. So that's 8, 9, 10, 11, 12, 13 tens. 130. So our 3 goes there. And our 100 out of the 13 tens goes below there. And then we've got 600, add 200, add 100, 6, 7, 8, 900. Just like we used to do at school. In year 4 are expected to add a pair of numbers going up to 4 digits using the formal written method. But again, we will always start with concrete apparatus first. So we have 4,235 added to 1,466. So if we do it concrete first, again we're trying to see if we can make 10. 2, 4, 6, 7, 8, 9, 10. That can be exchanged for a 10, which would then go there, and that wouldn't be counted. So we've got 1 left over there, so we have 1 unit, 1, 1. Then we've got to add these 10s up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't forget this one, 10. Oh, we've got 10 tens, so they all go. And we exchange that for 100, which would go there. I'll write 100 on because I haven't got a counter. So there's nothing in that column, so we put a 0 because that's our placeholder. So then we add our hundreds. 1, 2, 3, 4, 5, 6, and the one we exchange, 7. We have 7 hundreds here. And then we move to our thousands. We've got 4,000, add 1,000 is 5,000. So 4,235 plus 1,466 equals 5,701. Going to pictorial, we have 4,236 added to, combined with 1,466. So let's see if we can make a 10. We've got 6, 7, 8, 9, 10, so we can make a 10 there. This 10 ones will be exchanged and be moved into the tens column. We've got 1 left over. That's our 1 digit. We have 1, 1. Now let's look at the tens column. We've got 6, 7, 8, 9, plus this here. We've got 10 tens. So all of those can be exchanged for 100. And that will go there. We've got none left here. So we put 0 as a placeholder. That sometimes confuses children. Put 0 as the placeholder. We've now exchanged and our 100 is here. Let's add our hundreds up. 2, 3, 4, 5, 6, 7. We have 700s, and our thousands we have 4, 5,000, 5,701. If we go to the abstract form, which is a shortened, efficient written method, where we will just carry. So we have 5 ones, add 6 ones is 11 ones. So we've got our 1 there, and our 11 ones we exchange, that's our 10 now, because we've got a 10 and 1, 1. If we had our 10s, we have 6 10s, add 3 10s and 9 10s, not forgetting this one here. 10 10s is 100, so that goes there. And our 100 goes here, just like we did with the counters. Then we add our hundreds, we've got 400, 600, 700, and our thousands. 4,000 add 1,000 is 5,000. All children also have to add a pair of numbers that go up to 4 digits, which also could be decimals, but it is still a 4-digit number. So here we have 345 and 2 tenths, or 345.2, we say it both ways. We've got 345.2 or 2 tenths, added to 261 and 9 tenths. 261 and 9 tenths. So we'll start with the tenths column first here. And when we have our decimal points that do not move, I use magnets, they don't move. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths plus another one. So we've got 11 tenths. So we can exchange these 10 tenths, because 10 tenths make a whole, for that. So we have 1 and 1 tenth. So that 1 now has to go into the ones column. So how many tenths have we got left? We have 1 tenth left. There's our decimal point. Let's have a look at our ones. We've got 5, 6, Don't forget this one here that we've exchanged. 7 ones. Let's look at our tens. 2, 4, 6, 7, 10 tens. Well, 10 tens we all now make 100. That's equivalent to 100, so we can exchange those 10 tens for 100 and put that there. So we've got nothing there, so we need to put a 0 to hold that place. No hundreds. Let's look at our, no tens. Let's look at our hundreds. We have 3, 4, 5, 6. So 345 and 2 tenths added to 261 and 9 tenths is 607 and 1 tenth, or 607.1. Into pictorial we have 345.2 or 2 tenths combined with an added to 261 and 9 tenths or 0.9. So let's add our tenths up first. We've got 9 here and that other one there makes 10 tenths. Well, we can now exchange these 10 tenths and we can move 10 tenths to here because 10 tenths are a whole, which is a whole 1, which will go there. So we've only got 1 tenth left. There we go. There's our decimal point. We don't worry about that. It always stays in the same place. Let's add our ones. We've got 5 ones, 6 1, and this one that we've recombined and carried over, 7 ones. Let's look at our tens. We've got 6 tens, add 4 tens, is 10 tens. 10 tens is 100. So again, we can take our 100 here, because that would be combined and exchanged, and we have no tens left. And then let's look at our hundreds. 3 tens at 300 and 200 is 500 plus the one we've exchanged here is 600. 607 and 1 tenth or 607.1. If we move to abstract, it's very similar. So let's start with our tenths. 9 tenths add 2 tenths is 11 tenths. And the 10 bit out of it would go here because that's a whole. If we had the ones, 5, add 6, add 7, 7 ones. Let's look at our tens. 6 tens add 4 tens is 10 tens, it's 100. So again, this would move into the next column. And our hundreds, 200 plus 200 plus this one here makes 500. 507 points. In Year 5 and 6, children are expected to be able to add multiple sets of numbers with a range of digits coming from decimals all the way up to millions. So I've just gone from thousands to hundreds in this example. So in a concrete, we have 2,315, no decimals, added to 232 with 22 hundredths, or 0.22. We have 40.43, or 40 and 43 hundredths. We're adding 12.26 or 12 and 26 hundredths. So let's add the hundredths first. 2, 4, 6, 7, 8, 9. So we make, straight away when we add all these together, a whole 2, 4, 6, 8, 10. So that can now be exchanged because we've got 10 hundredths there. And 10 hundredths make 1 tenth, so that can be exchanged, and that can go underneath. So how many hundredths have we got left? 1. Then we look at tenths. How many tenths have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. We put our decimal point in. Let's add our ones. 2, 4, 5, 6, 7, 8, 9 ones. Let's add our tens. 1, 2, 3, 9 tens. Oh, lots of 9s here. Our hundreds, 1, 2, 3, 4. We've got 500. And so our total is 2,599.91, or we can also say it 2,599 and 91 hundredths. Pictorial, we have 2,315. We have no tenths and no hundredths. We're combining it with 232.22 or 22 hundredths. We're also adding 40, no tens, 0.43 or 43 hundredths, and 12.26 or 12.26 hundredths. So let's add our hundredths first. We've got 6, 7, 8, 9, 10, 11. So they make a tenth. We can exchange these 10 hundredths for a tenth and move this here. And we've just got the 1 left here. So we've got 1 hundredths. Let's look at our tenths. We have 2, 4, 6, 8, and this one here, 9. So we've got 9 tenths. Let's look at our ones. We've got 5, 6, 7, 8, 9. No exchanging here. Let's have a look at our tens. 4, 5, 6, 7, 8, 9. Let's look at our hundreds. We've got 5 and 2 thousands. 2,599.91 or 91 hundredths. We move to abstract. We can put the zeros in here as placeholders. And making sure everything lines up and our decimal point is lined up as well. So if we add up our hundredths, you've got 9, 10, 11 hundredths. That goes here because that's actually a tenth now. Let's look at our tenths. We've got 4, 5, 6, 7, 8, 9 tenths. Adding our ones, we've got 5, add 2, which is 9. Add our tens, we've got 3, add 4 is 7, 8, 9. Lots of 9s in this one. Hundreds, we've got 5. And thousands, we've got 2. 2,599 and 91 hundredths or 0.91.